Hi, everybody. Okay, so let's talk about rising sea levels and climate change. So, in order to start talking about that, we need to talk about glaciers. And I want to make sure that you understand just some really important facts about glaciers and what they do and what they are. So, a glacier is a large mass of ice that formed from compressed snow. Basically, it moves thanks to its own weight and the pull of gravity. Um, there are two different main types of glaciers, or lots of different types, but two main types are the mountain glaciers, or otherwise known as alpine glaciers, which are glaciers found in the mountains. The continental glacier, or ice sheet, is a continuous mass of unconfined ice that's bigger than 50,000 kilometers squared, or about 19,300 miles. As of 2021, about 10% of Earth's land surface is ice. This is mostly Greenland and Antarctic ice sheets. Glaciers are made of ice, okay? They're white, and white reflects sunlight and heat. So they help keep the earth cool. The less ice there is, the warmer it's going to get on this planet. Now remember that water absorbs heat. So melting glaciers and it creates a positive feedback loop of, melted glaciers means it's going to get warmer, and because it's warmer, it's going to melt more glaciers, and so on and so on. Now, glaciers begin to form when snow remains in the same area year round, and there's enough snow that accumulates to form into ice. Okay, so each year, new layers of snow bury and compress the previous layers, and the weight of the snow above forces the snow that's below to recrystallize and get more compact, which increases the density of the snow, and it essentially turns into ice. After a year, the snow turns into firn, which is a state between the snow and ice where it has about two-thirds the density of water. The large ice crystals in that snow ice firn thing become so compressed over time that the air pockets between those ice crystals are super tiny. They shrink. And the older the glacier is, the longer those crystals get. And that essentially is what makes glacier ice. Now, the structure of a glacier includes an ablation area, which is a place where most melting and evaporation occurs. Okay, you have crevices, which are giant cracks in the glacier, as in the picture right here. Okay, they're caused by friction where the ice moves rapidly and flows rapidly. You've got superglacial lakes, which are meltwater surface ponds that form, and you've got moulins, which are vertical channels formed by meltwater. So you've got basically structures in these glaciers through meltwater or through friction and stuff like that. Moraines are long, dark bands of debris that sit on the top and the edges of glaciers, and they form when the glacier pushes or carries rock debris as it moves. So as it's moving along the land and stuff like that, it's picking up debris, and so that those kinds of things like these bands form on those edges of the glacier. There are different kinds of moraines. There's the medial moraines, which are in the middle of a glacier, the lateral moraines, which are at the sides, and the terminal moraines, which are at the terminus or the end of a glacier. Okay. Now, when one glacier flows into another, you get a combined wider moraine. Okay. So it becomes a larger thing. Okay. The rock is left behind after the glacier melts, which gives us really valuable information about glaciers and the earth. So glaciers can move, but the weight of the ice makes it move pretty slow. All right. The movement on the bottom of a glacier is slower than the movement at the top because of friction. Okay. So the friction with the ground and the cold temperatures of the bottom of the glacier means that the top tends to move faster than the bottom. So sometimes you have the glacier that's sliding over a thin water layer, which comes from melting ice, and or it slides on soft watery sediment, which is called basal sliding. Okay. Now, glaciers retreat or advance depending on the amount of snow accumulation or evaporation or melt that happens. So, retreating is when the end of the glacier is moving down valley. Okay. Now, the thing is that or when the glacier end of the glacier doesn't move as far down valley as it previously did. Okay, so when it kind of seems like it's moving back north, if you will. versus an advance is when it's moving further down valley. So one thing you need to understand is that glaciers are constantly moving south. Okay, they're constantly moving down. So in the path of water, basically, like if there's a slope, it's moving down. Gravity is pushing these glaciers along, right? So retreat is when it seems to move up the valley, seems like it's moving in the opposite direction, and advance is when it's moving down in the direction of gravity. A terminus or a snout is the end of a glacier, okay? An end of the glacier at any point in time. Now, here's the thing. A glacier doesn't actually move backwards, all right? They don't actually do that. It always moves in a downhill direction, okay? So if you look at the picture here, it's always coming downhill. Okay, gravity's direction. Retreating glaciers are just melting faster than they can flow downhill. Okay, so before like the ice can actually make it downhill, they're just melting. So the actual physical ice is sort of seeming to move back, but it's really just that it's melting. Surging glaciers are ones that move forward faster than anticipated. So the physical ice seems to just surge forward downhill rather than, you know, slowly make its way down. Now, glaciers exist in high latitude and high altitude regions. So you see them in like this area right here, in Greenland and in Alaska, the northwestern United States. You see it in Antarctica and in South America and in the Himalayas and stuff like that. Northern Europe and in the Arctic. Okay, pretty much anywhere you see pink. You can even find some glaciers in Africa. Okay, they can be found on nearly every continent, and they're often found above the snow line, right? Because you got to have snow to make a glacier. They're mostly in the mountain areas or in polar regions. Glaciers actually do more than just exist as blocks of ice and move around melting. They shape the land beneath them because the ice basically erodes the land surface. It breaks up the land. It carries broken rock and soil far from where they originally were with this glacier. And they can create things like glaciated valleys, fjords, which the name might be familiar from Frozen. They're U-shaped narrow valleys that they were kind of gored out by the glacier, and then when the glacier left or receded, they were filled by seawater, and so it's like this U-shaped narrow valley. A cirque is when a glacier erodes a mountainside into a bowl shape. So it's like a bowl shaped mountain that's left behind after a glacier's been there. And Aretes is a jagged, narrow ridge. So this is a mountain that has jagged, narrow, sharp kind of mountains. Horns are when you have lots of cirque glaciers that erode a mountain until it's really steep, a steep pointed peak. Here are just some pictures of these kinds of things. So in this bottom left picture, you can see these cirques, which are like the bowl-shaped mountains. Here you've got these jagged ones. So those are the Aretes. Here you've got, I believe this one is, I think this one is a horn. And then here's just an example of flowing glaciers. And here's a fjord. Okay. So when a glacier retreats, the features and the sediments behind also shape the land. So moraines, remember those dark bands on the glaciers? Well, the material that's picked up or pushed by a glacier forms a ridge, and the ice eventually melts away, which leaves just that ridge behind, that material. There are kames, which are small, steep sided mounds of soil and gravel that form next to glaciers. So think of like, if you shove a piece of ice through some dirt, the dirt on the sides would start to bunch up, right? And so that's kames. Eskers is gravel that's deposited by rivers that are flowing on top of glaciers through cracks or in tunnels under glaciers. And so when the glaciers leave, the gravel that was moved by these rivers is often left in weird places, like it's left in a place that's elevated above the land surface, like on a mountainside or something like that. And it's not soil that originally was there; it just got moved by the glacier. Kettle lakes are small ponds that form when a piece of glacier ice breaks off and melts into the ground. So it's just a random lake that appeared because glacier ice melted. Huge rocks that are picked up along the way can be left behind, and you get things called glacial erratics or just erratic boulders. They are rocks, huge rocks that are out of place. They just randomly appear somewhere because they were moved by glaciers. Drumlins are long teardrop-shaped sedimentary formations. So all of the drumlins that are made by a particular glacier face the same direction. They kind of look like humpback whales, like all next to each other if you're looking at them from above. So let's talk about the ice caps and water, right? Now, 2.5% of the Earth's water is fresh water. Fresh water is water we can drink, okay? That includes freshwater lakes, soil moisture, water in the atmosphere, swamps, marshes, and wetlands, rivers, groundwater, and the glaciers and ice caps, okay? So if we look at this picture right here, the far left breaks down the global total water, which 2.5% is fresh water. Then breaking down that 2.5%, you've got surface freshwater, groundwater, and glaciers and ice caps. So that's the 31.1% and the 68.7. This is 68.7% of the 2.5% of freshwater is glacier water. Okay. 30.1% of the 2.5% is groundwater. Okay. Then you break down that surface and other water to these values. Okay. And so things like the soil moisture and the swamps, marshes, and wetlands, they are very small percentages of the whole. So that's what these really small percents are. I went ahead and did that for the first few, where you can see that they're actually really small. It's a very small amount of our actual water because it's a percent of a percent of a percent. These I didn't bother. So 97.2% of all the water on the earth is salt water. Now, many people get their drinking water from glacial water. Okay, people in China and India and Bolivia, places that are near glaciers or ice caps of some kind, that otherwise don't get a lot of rain, they get their water from glacial water. Many bottled water companies sell glacial meltwater or ice cubes made of glacier ice, and they like charge a premium for it because they're like, oh, this is like super fresh water from glaciers. Meltwater is also used to irrigate crops in the Himalayan areas of Asia, and they also do it in Switzerland and Europe. We can also use glaciers and those kinds of ice caps to generate hydroelectric power, and they've been able to do that in Europe, Canada, New Zealand, and South America. Scientists have taken many samples of many glaciers around the world, and they're able to get information about how the climate has changed. So a lot of information about what like that we know about climate change actually comes from glaciers because they trap gases and water and debris and all kinds of things like that, sediment and stuff like that within their bodies. And so as they melt, they finally expose this information that has been frozen for thousands of years. Okay. There have been several ice ages, we know that. Since the 1900s, glaciers around the world have been retreating at an unprecedented rate. So it was probably due to the Industrial Revolution that started in 1760. Several ice caps, glaciers, and ice shelves have disappeared completely. Um, the increase in global temperature plus increased dust and soot from grazing, farming, and burning fossil fuels have caused the retreating of glaciers. The World Glacier Monitoring Service, the WGMS, tracks the changes in more than 100 alpine glaciers worldwide. As the ice caps melt, they release water into the oceans. And as water takes more space than ice, this makes the sea levels rise. So most cities and human settlements are actually on the coast, okay, or they people live slightly at or above sea level, okay, which means that if the sea levels rise significantly, they're going to destroy several cities. Like even a 70-meter rise in sea level would displace about 2.4 billion people that live within 100 kilometers of the coast, including most of Los Angeles. Now, when the remaining ice caps melt, so the ones that are covering Antarctica and Greenland and all that kind of stuff, the sea level is probably going to rise about 70 meters. So it's that value, right? The 2.4 billion people getting displaced will happen when the rest of our ice caps melt. And that's basically 230 feet, right? Which doesn't seem like a lot, but it is. I think it's like the equivalent of like a 20-story building or something like that. So this kind of sea level rise would cover all the coastal cities like Los Angeles and New York. We would also have a lot less land area. Okay, a lot of that would sink. Some of these glaciers are in danger of melting right now. Like while the central Antarctic ice cap is probably going to stay frozen for a few more decades because they tolerated much higher temperatures. We're going to lose a lot of the other glaciers, the ones in Europe, the ones in the Arctic. We're losing those fast. Okay. Now, melting Arctic ice and permafrost actually also release a lot of methane and CO2. So, as they release methane and CO2, they cause a problem. They cause a lot of like warming of the earth and stuff like that because all that ends up in our atmosphere. So, it creates a constant problem. Now, this here is a picture, an approximated map, if all of the world's ice sheets melted. So this is all glaciers, all ice. So even if that Antarctic one melted, which would probably take a cool amount of time, like a couple decades more, than we're on track, already to lose. But it's a map of LA. So if you notice, okay, the Palos Verdes area right here would become an island because basically 90% of Los Angeles would be underwater. So up here, we've got Santa Monica. Here's where LAX was. You've got most of Hollywood underwater. So Hollywood sign, poop. Pretty much everything here. Luckily, the mountains right here would protect the valley, and so the valley would probably be fine. But we would basically become the new coast. The mountains right there would become our coastline, and then we'd have like the valley on this side. And so most of like Pasadena and South LA and, like all of that region, all the way to like Disneyland and stuff like that would end up underwater. And we would basically, everything up to San Joaquin would be underwater. Okay. So I think, let's see. Yeah, you can see like the different labels and stuff like that. So it's like pretty much a good portion of the of Los Angeles would be underwater. Most of it, in fact. So fun facts. Okay, on the left hand side here, you can see these are Google Earth pictures where they've approximated what these regions would look like underwater. So you can see that like a lot, like this is like, I think that's LAX or something like that. Like most of these places would be completely underwater. Homes would be destroyed. Like this is, what would happen in 2100 if the sea levels rose. So not only would sea levels displace people, rising sea levels displace people, but we would also have ocean circulation patterns and weather changes in the mid latitudes, like around our region and a little bit more north. Most of the United States, for example, would get more droughts, more wildfires, more storms. Some of our freshwater sources would get flooded with salt water. So the available drinking water that we have would disappear. We'd also have a lot of agricultural land loss because a lot of agricultural land, for example, is in areas where there's, very low, the sea level's low, where it's close to, sea level right now. And so losing those would mean that we would have less land for food. And so we'd have less food for a while. Increasing global temperature also leads to more severe storms and storm surges. We talked about this with the Weather and Climate Unit. Okay, like a storm surge is when water rises above its normal level and is pushed inward, usually by hurricanes and stuff like that. So rising sea levels would make that worse because the higher sea levels means more water gets pushed inland. And we would have increased rates of hurricanes due to warm climates. And so, also because wind moves more slowly in a warm climate, that would allow hurricanes to move more slowly. And right now, they move pretty fast. So the damage is limited because they can only destroy so much in a short amount of time. And once they hit land, they kind of peter out, their energy disappears. But if they're moving slowly, then that means that they can cause more damage and get farther before the storm destroys itself and implodes. And then also there are animals that rely and depend upon sea ice to survive and are likely to go extinct. Like polar bears live on sea ice, they live in the glaciers. And without like solid glaciers, they don't have anything to stand on. They drown basically. walruses, Arctic foxes, snowy owls like Hedwig from Harry Potter. Anyone remember that? Reindeer. Yeah, no reindeer for Santa's sleigh because they're all gone because they don't have a place to live. The organisms that depend on these animals also will go extinct. So we could see a big cascading failure problem of the food webs in these Arctic regions. Okay. And that's it. All right. So please go ahead and make sure that you finish your slides and turn them in. And I'll see you in the next one. Thanks, guys.